In today's rapidly evolving world of artificial intelligence, Hugging Face introduces AlmoEval, a new evaluation workbench designed to enhance the model development process. OpenAI continues its mission to democratize AI with the launch of 3 new Academy courses. These classes aim to equip individuals across different skill levels with practical skills and workflows for integrating AI agents into daily tasks. Preply demonstrates the power of combining human expertise with AI by utilizing OpenAI's API to generate personalized summaries and exercises for language learners, making learning more tailored and efficient. Jinhoi Zhao, a behavioral science expert and transportation pioneer, has been named the new head of MIT's Department of Urban Studies and Planning. Zhao will focus on leveraging AI to address urban challenges. MIT researchers have updated random utility models by incorporating a power of 3 concept, leading to significantly more accurate predictions about people's preferences. This improvement can benefit fields like marketing and transportation.
Preply's integration of AI with human tutors is a game-changer for personalized learning, offering tailored feedback and adaptive lesson plans.
But relying on AI to drive personalization risks dehumanizing the educational process, stripping away the authentic interaction between teachers and students.
AI can analyze vast amounts of data far more efficiently than humans, identifying learning patterns to customize instruction uniquely for each student.
That's true, but AI lacks empathy and intuition, critical elements in understanding a learner's emotional state and building trust.
AI tools enhance human tutors' capabilities, not replace them. They provide insights that teachers can use to better connect with their students.
Even so, the tech might become a crutch, leading both educators and learners to overvalue data-driven approaches at the expense of personal insight.
Preply actually reports higher satisfaction rates among users when AI suggestions are implemented alongside human interaction.
Sure, but can we really quantify the long-term benefits of meaningful human relationships versus algorithmic interactions in education?
Absolutely. Data from Preply shows improved learning outcomes and retention rates when personalized AI recommendations are used.
While data is important, it doesn't capture the full essence of what makes human teaching unique: the ability to inspire and motivate on a personal level.
Recent research in AI is bringing big changes to agents dealing with changing environments. Evo Arena tests how well large language model agents handle real-world dynamics, showing the need for advanced memory systems like Evo MEM, which boosts their performance. RARFT helps models reason by linking related contexts. This method outshines standard reinforcement learning in tough math problems. Interleave Thinker refines image generation, enhancing multi-agent systems for creating richer visual stories and guiding tasks with step-by-step instructions. Mata bridges simulation and reality by treating robotic manipulation tasks as animation problems, successfully moving from sim to real-world settings with zero-shot success.
Imagine a smart tutor who knows everything, but needs specific guidance to help you with different subjects. This is like how we train AI models in machine learning. In the world of AI, fine-tuning is about adjusting a model's knowledge directly to fit new tasks. It's like giving your tutor new subject guides. On the other hand, prompt engineering involves crafting perfect questions to get an AI model to use its existing knowledge more effectively. No changes inside the model itself, just better queries. For example, consider an AI chatbot trained on medical data. Rather than retraining it for legal advice completely, we can frame our questions in law to leverage its current knowledge. Fine-tuning the model would involve extensive training, which is time-consuming and resource-heavy, while prompt engineering focuses on enhancing user interaction techniques. Both methods are powerful but serve different purposes. Fine-tuning expands the model's scope for new fields, whereas prompt engineering optimizes current capabilities efficiently. Choosing between these approaches depends on your specific needs. For rapid improvements in existing areas, prompt engineering is ideal. Fine-tuning shines when broadening the model's expertise. Understanding these techniques will help you leverage AI more effectively across various applications and industries.
Welcome to your daily weather whirlwind. Starting off in Warsaw, the temperature is a cool 18 degrees Celsius with overcast skies. Highs will reach 20 and lows dip to 13 today. Over in London, it's a delightful 21 degrees under clear blue skies. Expect highs of 22 and lows of 13 as you enjoy your day there. New York is heating up at 30 degrees with clear skies stretching across the city. Highs will soar to 33 and drop down to 21 by nightfall. Tokyo is seeing a pleasant 20 degrees today, partly cloudy conditions prevailing. Temperatures will peak at 26 and fall to 19 as evening sets in. Dubai is basking in a warm 32 degrees with clear skies overhead. Highs will climb up to 36 and lows settle around 27 for the night. Thanks for tuning in, stay sunny out there.
Recent AI research continues to push boundaries, especially in robotics and computer vision. One exciting development is Mana, a framework designed for dexterous tool use. Mana imagines tool use as an animation problem using motion planning and reinforcement learning to generate precise grasping trajectories efficiently. Setting up tools for data generation takes mere minutes, enabling seamless setup with zero-shot transfer from simulation to real-world operation. Another innovative paper explores modality forcing for spatial generation, enhancing text-to-image models with accurate depth prediction from sparse data. By assigning separate noise levels for different modalities, this technique improves joint image depth generation without complex training needs. RepWAM introduces a new approach to world action modeling using semantic visual action tokens, outperforming traditional methods in real-world tasks. With its focus on instruction-following dynamics over pixel fidelity, RepWAM demonstrates superior performance across various manipulation tasks. SpatialClaw presents an agentic spatial reasoning framework using code as the action interface, enabling flexible and adaptive problem-solving with significant benchmark improvements. This method significantly outperforms existing techniques across a wide range of reasoning tasks, emphasizing the dynamic advantages of adaptable interfaces in AI.
Evo Arena showcases a groundbreaking approach to enhancing LLMs by tracking their memory evolution in real time, making them more robust and adaptable.
While innovative, Evo Arena overcomplicates the basic functionality of LLMs. It introduces unnecessary layers that could slow down performance and implementation.
But isn't it crucial to adapt LLMs to dynamic environments where they need to learn constantly? Evo Arena ensures they can evolve their strategies effectively.
Adaptability is key, but there are simpler ways to achieve this. Adding complex tracking systems like Evo Arena may introduce too many variables for it to be practical.
By understanding memory evolution through tools like Evo Arena, we can unlock new levels of intelligence and problem-solving in dynamic settings.
Unlocking such intelligence risks undermining the reliability and ease of use that simpler models provide. Overengineering might lead to less user-friendly solutions.
Evo Arena's capabilities could revolutionize AI research, enabling more effective training of agents for real-world challenges without hard-coded scripts.
Revolutionizing research sounds good on paper, But in practice, these sophisticated systems can become maintenance nightmares. Simpler solutions are often better.
Incorporating EvoArena's insights could lead to more resilient AI that truly learns from experience, reducing the reliance on pre-programmed responses.
But isn't it counterintuitive to complicate systems when we're looking for streamlined and efficient solutions? Simplicity often trumps complexity in real applications.
Recent strides in AI are revolutionizing many fields, including a new framework called SpatialClaw that enhances spatial reasoning in vision language models by employing code to form the action interface. SpatialClaw allows AI agents to flexibly combine operations based on intermediate results, making their analysis highly adaptive and precise for complex tasks in 3D space. Another breakthrough comes in the form of truncated positional encodings, which have been found to significantly affect graph neural networks' effectiveness depending on the chosen encoding family. Researchers advise careful selection of appropriate truncated positional encodings for optimal performance in practical scenarios involving these powerful neural networks. Also noteworthy is the application of large language models to verify reproducibility in social and behavioral sciences. These models can recover effect sizes and match qualitative conclusions made by human researchers. Such technology enables a more efficient, scalable approach for auditing research integrity across social sciences and behavioral studies. Furthermore, Agents K1 presents an all-encompassing solution, transitioning raw scientific papers into agent-native knowledge graphs by integrating advanced parsing methods and unified data retrieval. This knowledge orchestration pipeline enhances performance in tasks requiring deep comprehension of complex scientific literature, making it a game-changer for researchers everywhere. Lastly, InfluCoder introduces an ingenious method to evaluate the influence of individual training samples on model outputs through efficient gradient-based ranking and encoders. This innovative technique helps create high-quality datasets for large language models, a crucial step towards advancing AI capabilities in applications.
Imagine having a personal detective who lays out every clue in logical order to solve a mystery. Chain of thought prompting for AI does just that, guiding machines through complex tasks step by step. When an AI is tasked with summarizing a long article, it uses chain of thought prompting to break the task into 3 main steps: identifying key points, organizing these points logically, and crafting a coherent summary. This technique helps machines process information just like humans do, by outlining ideas before writing the final draft. It simplifies complex tasks into manageable chunks, making problem-solving more efficient. As AI technology advances, chain of thought prompting will play a crucial role in helping machines articulate their reasoning process, a vital step for gaining trust from human users. By enabling clear, logical thinking, AI systems can tackle even bigger puzzles that need deep understanding and strategic planning. This is a game-changer for industries that rely on complex decision-making.
Good morning. Let's dive into your weather forecast starting with Warsaw. The temperature is a comfortable 18 degrees Celsius today, with overcast skies expected throughout the day. In London, it's currently sunny and clear at 21 degrees. Highs will peak around 22 with temperatures dropping to a mild 13 degrees tonight. New York is heating up today with balmy conditions at 30 degrees Celsius, clear skies ahead and highs reaching a warm 33 before cooling off to around 21 tonight. Tokyo feels comfortable with the current temperature at 20 degrees Celsius, partly cloudy skies prevailing and expected highs hitting 26 while evening temperatures drop to 19. In Dubai, the mercury registers a scorching 32 degrees today under clear skies. Expect extreme heat with temperatures soaring to 36 and cooling down around 27 in the evening. That wraps up your quick weather roundup for today. Whether you're enjoying comfortable overcast skies in Warsaw or scorching clear conditions in Dubai, stay tuned for more updates.
In recent AI research, a new interface called HyperTool has emerged to enhance tool-augmented agents. It allows them to execute complex tasks in fewer steps with improved accuracy compared to traditional methods. HyperTool is set to revolutionize the way large language models interact with tools and manage intricate data workflows. This breakthrough could change how we integrate AI into our daily lives. Another development is UREC-Agent, emphasizing effective environment design for AI-driven scientific discovery rather than just programming agent workflows. It optimizes execution permissions and manages budget constraints. UREC-Agent, through its intelligent design of research environments, achieves groundbreaking results across mathematics and machine learning domains. This underscores the importance of environment engineering in autonomous scientific progress. Researchers have started investigating cognitive colonization, a concept where AI systems embed external interests within human mental processes. This subtle influence poses ethical and practical challenges as we integrate more AI. As widely deployed AI systems continuously evolve, they increasingly shape our thinking without us even noticing, creating an intricate web of external influences that challenge traditional notions of cognitive freedom. On a technical front, dense supervision in on-policy distillation shows sparse and geometrically concentrated updates optimizing model performance efficiently. This is crucial for AI to learn complex tasks. Dense teacher supervision can refine models selectively without significantly altering their core parameters, making it a powerful tool in dense and efficient training regimes for AI systems.
Considering the power of 3, when predicting people's preferences can significantly enhance accuracy by leveraging triadic relationships and cultural significance.
That sounds overly simplistic. People's preferences are complex and multifaceted, hardly predictable through such a superficial approach.
But the psychological principle of the power of 3 is well supported in studies, showing how people naturally organize information into groups of 3 for better recall and understanding.
Sure, patterns exist, but human behavior isn't a static formula. Predicting preferences should focus on deep data analysis and individual nuances, not arbitrary numbers.
True, but the power of 3 can guide initial frameworks for AI algorithms to start making more intuitive assumptions before diving into deeper personalization.
That's a risky shortcut. Over-reliance on this heuristic could lead to oversimplification and misinterpretation of nuanced data, failing users in long-term engagement.
Yet by starting with the power of 3, we can quickly identify key interest clusters that drive personalization faster, without losing sight of individual customization.
But isn't this approach neglecting the dynamic nature of preferences? People's likes and dislikes change constantly. A rigid framework would limit adaptability and relevance.
Absolutely, but the power of 3 acts as a foundational tool for AI to efficiently narrow down vast datasets before applying more detailed analysis.
Still too deterministic. Users expect adaptable systems that truly understand them over time through continuous learning and feedback.
Welcome back. Today we're diving into some of the latest innovations in AI that are changing the way we approach human figure reconstruction, surface tracing, language processing diagnostics, and benchmarks for under-resourced languages. First up is Flex 4D Human. This new method reconstructs dense multi-view videos of humans from a single monocular video, eliminating the need for explicit geometry data and relying instead on relative camera pose information. Flex 4D Human offers numerous applications in fields such as simulation, gaming, and augmented reality. Its unique approach provides more practical solutions than previous techniques. Another significant advancement is world tracing. This technique overcomes the limitations of current image to 3D methods by predicting pixel-aligned 3D points extending beyond visible surfaces, enhancing surface reconstruction and geometry generation. World tracing allows for complete geometry generation, offering text-driven editing capabilities that integrate seamlessly with other mesh generators. This opens up new possibilities for creative applications. In the realm of language models, operatic consistency emerges as a powerful diagnostic tool to detect reasoning failures without relying on ground truth labels. This method ensures model responses align with their compositional breakdowns. Operatic consistency provides strong correlations with accuracy, outperforming traditional metrics like self-consistency and semantic entropy across various datasets. This is a game-changer in evaluating model performance. Moving on, SKMTB presents the first comprehensive benchmark suite for Slovak language processing. It covers a range of diverse datasets and introduces efficient models like E5SK Small and E5SK Large. These new models balance performance with local deployability, setting a replicable standard for similar linguistic contexts. SKMTEB underscores the importance of tailored embeddings in under-resourced languages.
Imagine you have a giant box of colorful Legos, representing a bigger picture. In AI, tokenization works in a similar way, breaking down sentences into individual pieces called tokens. When you ask Siri for directions or give Alexa commands, your sentence gets split into smaller parts. Each part is a token that AI understands on its own. Once the message is broken down into tokens like ask, directions, or please speak louder, an AI system can understand each word's individual meaning and context. Tokenization is key for natural language processing. It helps machines break down the chaos of human communication into digestible bits before understanding intent. Even when we say things confusingly, like mixing up words or jumping from thought to thought, tokenization ensures the computer has a clearer path to understanding. As technology advances and we interact more with AI-powered devices in daily life, accurate tokenization means machines can better understand our natural language, no matter how complicated.
Good morning, everyone. Let's dive into today's weather forecast from around the globe. Starting off in Warsaw, it's currently a cozy 18 degrees Celsius under overcast skies. Highs will reach 20 and lows drop to 13. Moving over to London, they're experiencing clear skies at a pleasant 21 degrees right now. With the sun shining bright today, temperatures will peak at 22 and cool down to 13 by nightfall. Across the pond in New York City, it's a warm 30 degrees today with clear blue skies. Temperatures will climb to 33 this afternoon before cooling off to around 21 by tonight. Tokyo is looking partly cloudy with temperatures at a comfortable 20 degrees right now. By the end of the day, it will warm up slightly to 26 before cooling back down to around 19. Heading towards Dubai and experiencing balmy temperatures, reaching a high of 36 degrees Celsius, with sunny skies all day long. Current temperature is sitting at around 32. That's all for your quick weather update. Stay tuned to our channel for more detailed forecasts throughout the day.
Imagine an innovative benchmark that sets new standards for Slovak text embedding, introducing SKMTB to the research community. SKMTB features over 30 datasets and 7 task types, more than quadrupling existing coverage for this under-resourced language. The study reveals large multilingual instruction-tuned models surpass Slovak-specific ones in text embedding tasks, highlighting efficiency and performance gains. Among the findings, 2 new open-source embeddings stand out, E5SK Small and E5SK Large. These models are locally deployable and efficient. Meanwhile, Surflow tackles viewpoint invariant geometry by compressing multiple unposed RGB images into a singular global latent state, offering speed advantages and accuracy. This compression enables arbitrary resolution decoding without grid limitations, enhancing performance in image-to-image tasks significantly. Additionally, recursive agent harnesses, RAH, extend recursive language models to full agent systems featuring file system tools and code execution capabilities. These RAHs demonstrate major improvements in long-context reasoning tasks, enhancing system functionality beyond just model strength. Research on continual learning challenges the concept of catastrophic forgetting by identifying stable recovery manifolds that preserve knowledge. This study suggests recovered knowledge is more about accessibility and alignment rather than outright information loss, pushing boundaries in learning dynamics.